This video is on concentration, what it is, and how to calculate it. So liquids and gases can be easily quantified by measuring their density. This gets a little more complicated with solutions because now we have things that aren't pure, so we can have different amounts of solute and solvent, whereas liquids are pure. That's the difference between them and a solution. Liquids only contain one thing. So we can quantify solutions through concentration. So the concentration of a solution is determined by the moles of the solute and the volume of the solution. So right below this, I can write that concentration is moles of solute. So that's what you have less of, right? That's what gets dissolved, divided by the volume of the solution, which means the whole thing. The solution, remember, is the solute and the solvent. All right, so when it comes to an equation, we can shorten all this up. So we can use C for concentration and N for moles and V for volume. So this is our equation. So we have moles divided by volume units, which are liters. So our units, nothing divides out, is moles per liter. You can write it like this. Sometimes we'll write it side by side like this. So you might have to do some conversions though to get to this point. You could be given mass where you have to convert to moles, and you could be given milliliters, which you can convert to liters. So when we're talking about the concentration of a substance, we put that substance in brackets. So for example, instead of saying the concentration of hydrochloric acid is 1.2 moles per liter, we can just put HCl in brackets like this equals 1.2 moles per liter. Okay. All right. So let's use this information now and find a concentration mathematically. All right, so we're given the grams. It says the solution prepared by dissolving 7.75 grams of C6H12O6, which is glucose, in enough water to make 450 milliliters of solution. So this is our solute, right? This is our solution. We want to know the concentration, so we're going to use this equation in green. So we don't have moles and we don't have volume in liters. So we're going to calculate that. We've got mass, right? This is mass. So we're going to find our moles by taking our mass, 7.75 grams, because we know what it is, C6H12O6, and we're going to convert it to moles. So we want to get rid of grams. We want to go to moles. This is where we use our molar mass that we calculate from our periodic table. So remember, that's how many grams there are in a mole. So I add up the mass of carbon, right? There are 6 carbons. So this is going to be 6 times 12.01 for carbon. I'm going to have, let's see, 12 hydrogens times 1.01, and then 6 times 16 for oxygen. So if I add all these up, this ends up being 180.18. Okay, so my grams of this divide out unit wise. So then the numbers, I'm going to take 7.75 divided by 180.18, and this gives me 0.043 moles. Now, this is a small number, and sometimes kids are like, oh, this is really small. Moles are going to be small numbers typically. Remember, there are 6.02 times 10 to the 23rd atoms in 1 mole. So this is normal. All right, so the last piece is, before we can get to our equation, is we have milliliters. So we're going to go to, we have to go from milliliters to liters. So 450 milliliters, remember to go to liters, you're dividing by 1,000, which is 1, 2, 3 spots to the left. So this is 0.450 liters. All right, now we have the correct things that we need, and we can find our concentration. So concentration is our moles over our volume. So 0.043 moles divided by 0.450 liters. We type this in, 0.096 in our units, nothing divides out, so we just write them as is, moles per liter. So that's the concentration of this solution. The higher the number, the more concentrated it is. The lower the number, the less concentrated or more dilute it is. So that's what concentration is and how you calculate it.